Hey everybody, welcome to the tutorial session number 4, which is entitled Machine Learning Bias in Computer Vision, Why Do I Have to Care? My name is Sandra, I am professor in the Institute of Computing in the University of Campinas, Brazil. And today I'm going to be the chair of the sessions, it's about 3 hours. And let me remind you that you can ask your question on YouTube chat or in our Discord channel. So I'm delighted to introduce you our speakers, briefly introduce because I know they will introduce themselves. So Camila Laranjeira is a PhD candidate at the Computer Science Department at the University at the Federal University of Minas Gerais in Brazil, and Virginia Fernandes Mota is a professor at the Informatics Department of Caltech, also at Federal University of Minas Gerais. So I would like to thank you all for being here, and Camila and Virginia, the stage is yours.
Thank you.
Thank you.
Can we have the presentation? Okay, thank you. So good morning, everyone. Thank you for being here today. We're gonna present a little bit about machine learning bias, which is a growing topic right now. And we'd like to bring it closer to our community and talk a little bit about the impacts of what we do, of what we research, and sometimes we might not even notice the impact we're causing in the world. So let's start with brief introductions. So this is a very light presentation, so please feel free to ask questions anytime, and I would like you to know us a little bit better before we start. So this is me, and this is my headpiece that's usually here with me when I'm working. So we're home office, right? So we usually have pets all around the house. And if you come into my office unannounced, that's the image that you get, me with a bird in my head. So I'm a PhD candidate, as Sandra told us earlier. And I'm currently researching about ethics and AI, specifically in the context of child sexual abuse in images. And I'm working on an ethical pipeline for detecting such images because it's a very sensitive topic and we cannot just train machine learning models without caring about the subject. So I'm researching a little more about the subject from the perspective of computer science. And I'm also a science communicator on YouTube here, where you're watching this right now. And I have a YouTube channel. If you're interested about ethics and machine learning and AI, you can check. Unfortunately, it's only in Portuguese, but if you speak Portuguese, you can check our YouTube channel.
And hello, everyone. I'm Virginia. I'm a professor at Informatics Department of Caltech. This with me, it's Turing, my dog, and he's also here. Maybe he will snore a little bit, but it's normal. I have a PhD in computer science in the field of machine learning and computer vision at UFMG, Federal University of Minas Gerais. Now, as a professor, I have a lot of branches of research. So I'm still studying a little bit of ethics and AI together with Camila. I'm also researching the area of accessibility in digital games. Yesterday was on SB Games that is going on together with SIBGRAPI. And I'm also research on education and science communication. I'm together with Camila in Peixe Babel channel on YouTube.
And finally, the last author of the paper, he's not here right now, but his name is Jefferson dos Santos. He's a professor at UFMG. He's actually my advisor. And he's also head and founder of the lab I'm currently working, which is called Pattern Recognition and Earth Observation, PATRO. And he's also a level 2 productivity at CNPq, and he has a scholarship. And I'd like to introduce briefly the works Patrio is currently working on, because although it is called Earth observation, remote sensing is just one of our lab's work. There's also a very important branch of, working with medical images, and the third branch, which is the one I'm working on, which is forensics. And we're working on one of the global goals from the United Nations, which is protecting children from violence and harm and abuse. So those are the three main branches our lab is working on. And before we start the presentation, we would like to apologize in advance because we have a lot of animals in this house. So eventually you might hear some dog barking or bird screaming or something. So we apologize in advance, but it's part of the home office thing, right? And okay, let's start. You can ask questions anytime, and we encourage you to ask questions because this is a tutorial. So we would prefer if this is a conversation, an exchange between us and you who's watching. So please ask questions both here at YouTube and also Discord. We're going to be checking at all times. Would you like to start?
Oh, okay. So we'll briefly with an introduction. Our main motivation here is to show you that when we are working with computer vision and machine learning, we normally use some human-centered applications, and we start with working with humans. Well, our final user may be a human too, so it's important that we start to think about all those problems that we will present here before our final deployment, before it gets to our final user. So just to show you some little motivation of something old, can you?
You're
Okay.
not. Okay. So the outline before we go on, just so you have an
Okay.
idea of what you would expect from this presentation. So we're gonna make a brief introduction, about 10 to 15 minutes, and then we're gonna spend a lot more time talking about the types of bias, some study cases from the literature, and then some solutions, or at least some attempts at solving the problem of bias. So we're gonna have two breaks during this presentation. One right after we introduce the types of bias, and one after the study cases. So you have a lot of bathroom breaks, so you can be here with us at all times. Okay, so please go on.
So, starting with our motivation, we have something old. It's more than 10 years, so it's already old. When cameras is starting to show some, you can shoot an image, a photograph, but only if someone is smile or blinking. The old cameras would show something like this. This is a woman of an Asian heritage with the eyes are not Western. So the camera says, did someone blink? This is very aggressive for some cultures. So was old, but you can say, okay, it's more than 10 years. It will never happen again. So they already resolve everything. And last year, in 2020, with the passport, it's the visa passport of London. I
London,
think
right?
it's London.
Yeah.
It's London. A black woman was uploading her picture to the site for the visa and passport, for a new passport, and the site said, your mouth is open, because, well, of course, she's a black woman, and maybe the data set of this site was not quite well trained for
Mhm.
people different from the what they say it's a pattern for them.
And I think the most aggressive thing, besides a biased model and everything else, is the reasons they list for why is your would your mouth be open. So it says maybe the image is too dark, or maybe you have a medical condition that requires your mouth to be open. So someone decided that there's no way the model could be wrong, right? So if you're uploading a picture and it says your mouth is open, we should assume it's right, and you should fix the photo, and we should not fix the model. So I think this is even more, it's part of what we're going to talk about. This is the automation bias, right? So we rely so much on technology that we don't open the possibility, we don't accept the possibility of our models being wrong. Rather, the input is wrong or the user is wrong. So just a little bit about machine learning pipeline, because we're going to be talking about biases throughout the machine learning process. So you're all, I guess, familiar with this pipeline, but try looking at it from a human perspective. This is a very important exercise. So when we're talking about machine learning, we're not talking about uh, stuff that it's unchangeable. I don't know how to best put it. We're talking about human choices. So from data collection to data annotation and choices we do at pre-processing and all sorts of things we do with the data, it's about human choices. So you can have the exact same type of observation, but two different researchers will collect it different, will annotate it differently, will pre-process it differently. So this is all human choices, and it can highly impact your results. The same goes for the algorithm. We make choices of what constraints we'll use, what loss functions we'll use, and this all impacts the results of your model in ways we may not notice. Same goes for results, right? We all know that we can shape results in a way to make it look better, to make it highlight something that we're good at, right? We want to highlight the thing that works in our methodology. So we choose the metrics and how to aggregate the metrics and how to analyze what to highlight. And this is all human choices. And it will impact how people see our work and what they understand of what we did. And deployment is where it can all go wrong. So this is when you involve humans, and this is usually when we think about humans at deployment, but we should be thinking about them from the start, from data collection.
And here, when we talk about bias, we are not talking about the bias of a neural network or a mathematical bias. We are talking about bias in ethics and fairness research. Fairness here in machine learning, we say about, refers to the attempt to correct algorithmic bias. So when we talk about bias in this field, we are talking about stereotyping, prejudice, or favoritism towards something, people or subgroups or minorities in general. This is the definition of Merriam-Webster dictionary. And another thing we can say about bias in ethics is the systematic error introduced by a sampling or reporting procedure. And as we say on the machine learning pipeline, we can see that this systematic error can be found in every step of the way.
Yes. And this is just so you don't get confused about bias in neural networks or machine learning. We're talking about bias as in ethics and fairness. So, bias is a broad concept. We're going to talk about dozens of types, and there's even a lot more, but we're selecting some of the most important that we should be paying attention to. And I think that the most important thing we're going to talk about here is that a single work may contain more than one form. It means that there is not like what is the bias of my work. No, your work probably has several biases throughout the process: data bias, algorithm bias, and so on. And you should be paying attention to every single step of the process. And there's no single solution. So, of course, if you have dozens of types, you're also going to have hundreds or thousands of solutions, right? And it can happen in every stage of the pipeline, and that's what we're going to be highlighting. So this is a very interesting talk that I recommend everyone watches. Is from Margaret Mitchell. Yes, her name is there. It's from Margaret Mitchell. It's called Bias in the Vision and Language of Artificial Intelligence. So she highlights both computer vision as a field of research, but also language models, which we know is a very popular topic right now. And there is a lot of issues with this research. So this snapshot that I got from the video is just so we have an idea of what we're talking about when we say humans are biased. We all are. Nobody is exempt from it. So this is a short story, kind of a joke. A man and his son are in a terrible accident and are rushed to the hospital in critical care. The doctor looks at the boy and exclaims, "I can't operate on this boy. He's my son. How could this be?" So, if a man and his son are at the hospital, how can the doctor say that this boy is my son? So, this is a joke that ends up revealing that the doctor is the mother and not the father. So, this is just to say, thought experiment that we think about doctors as male doctors and not female doctors. And it takes us a little while to understand that the doctor in the joke is the mother and not the father. And this little while it takes us, this effort we make, this is a clear example of why we're biased, and we should be paying attention to that. So, introductions are done, and let's go to types of bias. As we said, there are dozens, and the ones we're going to show here, it's not the entire universe of bias. There are more, but we selected a few, enough for us to understand how bias can affect every single step of the way. So, this is the ones we're going to talk about. Do you
Oh, sorry.
okay?
Yes. These are the ones the most important on machine learning research that we selected for you. You can see sometimes the name of the bias may be different in different literature, but the meaning is the same. And also we start to show some works here that may or may not have this kind of bias, but then on the study case we will show much more of these questions. Some of this bias that we will say are on the pre-processing pipeline, or maybe on the model, or on the deployment. So there are bias for every stage of our work.
And some of them are closely related. For instance, selection bias and sample bias are closely related. So some of them will be introduced in pairs and some by themselves. So let's start with selection bias, which refers to when these selected individuals do not represent the real world. So if your data is different than the application used, then you might be suffering from selection bias from the perspective. For instance, if you collect the data with one specific camera, but your application uses a different camera, so you're suffering from selection bias because your data is not the same as the real world, and this might impact performance in a way that you cannot predict. But you can think about it from the perspective of incorrect partitioning of data. So, if the training set has a completely different distribution from the validation set, you can have a kind of selection bias, lack of randomization, and so on and so forth. On the other hand, sample bias is when the available sample of the population is skewed, is biased, right, towards a specific group. So this is two different issues, because selection bias means you're selecting data in a wrong way, and sample bias means the available data is biased towards, is favoring some specific group. So it's not actually your fault, quote unquote. The data is biased. So the example we're putting here, and we'll talk about it a little more in study cases, is Celeb Faces. You might know it like that. It's a face recognition data set with faces of celebrities. And we know that celebrities, the most famous one, maybe they're from the United States or North America and Europe, I don't know. And they're mostly white, and the majority of them are male. And we have this skewed distribution that does not favor minorities and some specific groups. So Celeb Faces is a data set involved in several cases of bias, and we're going to talk a little bit more about that on the next section of this presentation. Go
And
on.
for measurement and for measurement bias, we say normally when it refers to faulty, low quality, and unreliable measures when collecting data. When we are working with data sets and large data sets, we often have insufficient label for our objects or person on example. Even if we have labels enough, we can have just binary gender on a face data set as celeb. We have also problems with abstracted concepts when we say about emotions and sentiments. This is very common on NLP, on language processing. And one of the main problems that we see, and it's very interesting in this work that we will talk in the study case, is the poor training of these labelers. If we have to label something, if we have to label our data set, and we do not train well our labelers, we cannot just say that they will have a good work. This is very interesting on the subject, as this image I can this image on the of a marriage, and the question is what's a marriage, and it's just there is just a one bound box on the woman, because marriage normally just reminds you of a woman in a white dress. So
Western marriage,
a
right?
Western marriage, so it's already a little biased in this. And the subtype of bias that we found a lot too is the recall bias, that we see in this label inconsistencies for the some subject views from the labels. But this one is a really interesting, because sometimes inconsistency is really good to have, but sometimes don't. So we will talk a little bit more on this study case.
And this is recall bias is interesting because it means it generally means the concept you're labeling is very abstract, and it depends on interpretation from the labeler. So whenever the inconsistencies arise from subjective views, for instance, what sentiment is this image portraying? So this is recall bias because it sources from a subjective view of the labeler. And this is actually a very interesting work. We're going to talk a little bit more in a study cases section, but you can ask yourselves like why there's only a label for the woman or only a label for the child on the upper picture. This is a labeling process where labelers are instructed to draw bounding boxes around automatic labels. So I'll explain in further detail, but the labelers receive automatic labels and they should draw bounding boxes around those labels. So you can guess from the military picture, there's no automatic label for woman, and from the marriage, there's no automatic label for the man. So we're going to talk a little bit more about that in a study cases. Automation bias. This is a very, very, very important one because every day we're relying much, much more on automatic models. And when we think about automation bias, when I first read about automation bias, I thought about deployment, the person who's using the software. So automation bias means that I'm gonna rely on automatic decisions instead of thinking about those decisions, right? So we're depending so much on automated systems that we don't question those decisions. But when you start looking at it, we as machine learning researchers, we as computer vision researchers, we're relying even more on automatic signals to do our work every day. One example, a very, very strong example, is this paper called Large Image Datasets, a Pyrrhic Win for Computer Vision, question mark. Because ImageNet and the Tiny Images dataset, those are large scale datasets, and the process of data collection is almost all automated. So this led to some very peculiar labels. We're going to talk a little bit more in the study cases, but here you can see that the Tiny Images dataset had labels like I don't know which one I can say out loud here, but
Yes, I
uh,
don't know if you can say those
but
words
I
here.
guess it's best if you read the picture, the Tiny Images dataset, the graphs, look at the labels below here. Those are some labels that really they were in the data set before the data set was removed, of course. And the same goes for, oh, this is Tiny Images as well, but we're going to be talking about ImageNet and the study cases and what they found um, due to the automated process of data collection. So this here, some of those labels are not even imageable. Like how can you picture a I'm not okay. How can you picture a child molester, for instance? You cannot, right? Unless you're being judgmental or you're putting your prejudices onto the imaging. But there's no picture that represents those kinds of categories. So this is due to automated data collection, and we are relying much, much more on automatic data collection to build large-scale data sets, right? Because it's not possible to label millions, tens of millions of images with the required precision for a high quality data set. So we just pretend it's a good data set and go on using it. Yes, more about automation bias. Would you like to introduce this one?
This one, as Camila had said, we always think about automation bias at deployment, and yes, there are. This one is a terrible example, I have to say, because this is a tool that on the United States is widely used. Is the Compass. The Compass is a risk assessment tool. They based on the picture and the records of uh, the felonies of the felonies
It's
they
questionnaire, like what
Yeah,
crimes
it's
did
a
you commit?
questionnaire, yes. And they say if they have the kind of a grade to say if it will be reincident or not. But what we see here, this was a very good work of the ProPublica, and they show that black men are way more bad graded, let's say this, bad graded than the white men. And even when we see the type of crime that has been practiced, we see that for black men and black women, all every time the grade was very poor for them, while for the white man and the white woman it was always okay, it's always low risk than the black people. And we will talk a little bit more on this subject, but this was widely used, and it was just 4 years ago they start to question these arrests that they have done.
And this is the text on this slide is a quote from ProPublica, and they talk about this case where the judge already had accepted a deal, right? So the person wouldn't have to go to jail. And when the judge looked at the output from the system, it was so high risk that he thought, I cannot let this man go free. And he decided to overturn the plea deal, and the person was arrested for 3 years because of shoplift, I think, something very like
It's very
ridiculous,
small.
very small felony. And when the judge looked at the risk assessment, he decided, well, if the system is saying that he's a high risk, I should put him in jail, right? So if we release those systems, if we say that, oh, my system has a 90% accuracy on risk assessment, we're saying rely on the decisions of our system to make decisions. And we might think like, this judge is wrong, he shouldn't be doing that, he already decided what he wanted to do. But we cannot expect that everyone will question automatic systems. Think about the first thing that goes on your mind when something goes wrong on your computer. Do you think, is the system wrong, or did I do something wrong, right? This is kind of the automation bias in our everyday lives. We maybe, as computer scientists, we think probably the system is wrong, but people outside of our community, they think, did I do something wrong? They don't question the system. So we should be thinking about that when we put things in the world out there. Expectation bias and confirmation bias. This is one that I pulled a very interesting paper outside of the computer science field. This is a physics paper, and I would love to see one of those for computer science, because this is a selected history of expectation bias in physics. So expectation bias is when our expectations and our world views impact our actions. So when we choose what to work on, when we choose what methods to use, when we choose what data to use, this is all based on our understanding of the world, what we think it's worth working on, right? So this selected history of expectation bias is so interesting. It's about how even Newton and Einstein, they were so confident on their about their work that they made rude mistakes. So it talks about I think it's Newton's work, that he For years he thought that he had this pipeline all defined of how to reach this conclusion, this physics model. It doesn't matter in this case, but he had all these filtering steps and all these decisions he made along the way to make his theory match the observations. So he had an observation, the math was not working, so he added so many extra steps to make his math work with the observation. And for years people thought it was right, but it was just overconfidence of Newton on his math. And it was actually a lot different. And they only started questioning Newton many years later. So it's just about our expectations. Like, if, for instance, if you're developing a solution, you're developing this very deep neural network, and you're comparing against this baseline, whatever it is. So if your deep neural network that you put so much effort on, if it's better than your baseline, then you don't double check, you don't check your implementation. But if your solution, your very good solution, is worse than your baseline, then you're gonna take a very deep dive on your code, see if there's any bug in there, because you're expecting it to be better than the baseline, right? So this is just that, so we understand that if everything goes right in our pipeline, we don't double check, and this is a kind of expectation bias. So this is tightly related to confirmation bias. This is when we favor some data or some model in accordance with our own belief, and it's tightly related to expectation bias, in a sense that both refer to our expectations on the world. And it's worth reading about expectation bias in physics, because it might make you question yourself and your decisions throughout the process of research. It's very interesting, and it's very fun to read how, for instance, Galileo thought Saturn had two moons and not one ring. And for years, very many people developed this two moon theory, because Galileo said it had two moons, so it's probably right. So it's interesting. You should read that.
And when we talk about machine learning, we talk about metrics and benchmarks and everything in between. But when we want to compare with the literature, normally we use some widely accepted metric in the literature. But this might have a little problem. When we say about evaluation bias, we say about misrepresentative benchmarks and poor metrics, even if it's widely accepted. Um, this work that we brought here was a CVPR work on from last year, I believe 2020 or
Yes,
2019.
29,
2020.
2020.
2020, and it was it's a kind, it's little a kind of expectation bias too, because everything was okay. The author put on Twitter, oh look, we are doing a really great work here of upsampling a very poor quality image, and we can create a real good image from that. But when it posted on Twitter and people started to check, let's say that it starts to run this algorithm with faces that aren't Western and they aren't white. We had something like this white Obama and this, well, something that looks like a black face. If you don't know what's a black face, is a really prejudice thing that it was common on the early 1920s. So we see here that we have a little bit of expectation bias too, but also an evaluation bias, because with the metrics on the literature, with the precision and accuracy, it was very good and it was okay. But when we started to look a little more into the algorithm and into the model, and we say, well, this doesn't work with black faces. This doesn't work with woman faces too. We had some problems. We will discuss it a little later. So we see that this evaluation bias is present. It's interesting that post that is this work later released a model card to show that this leads to evaluation bias, and they show, yes, our face super resolution may not work with everything. Our accuracy is very good for white faces.
And this is very interesting. When he says evaluation bias, he's also talking about the data set, because he tested on celeb faces, the data set of celebrities, which is mostly white, and he thought the model was great. And it's interesting that we say our model is able of upsampling images of faces, when we should really be saying that the model is good at upsampling images of white faces. Because for any images, and believe me, I tested many images, famous people, anonymous people, celebrities, and always with a black face, it does this whitewashing, or in worst cases, this black face over a white person. And the evaluation bias is, if you use a data set of only white people, you're not going to notice that your model does not work for black people or Asians or any Midwestern people. And you should question the benchmarks, the data set that you're using, because it might be hiding important bias. Especially, like, we are Brazilians, right? We're not mostly white. There is a lot of mixed heritage. There's a lot of black people in Brazil. So if we want to deploy models or apply models to our country, we should be questioning benchmarks, which are mostly from North America, white people, and etc. We should not rely so much on them. And do you want to present this one? This is a
I
terrible
don't know.
paper. I'm just gonna
Yes.
start saying this is a terrible paper, but it's worth showing here. Believe me, but please.
Yes. I think the main thing is that machine learning solutions are becoming more and more pedestrian. So if everyone is using some machine learning solution, some computer vision with machine learning solution, we have to take care of something, some little details. This work is from a journal. It's a good journal in
It's a good
psychology.
journal.
It's a good journal, but yes, the assumption of this paper is that with deep neural networks we can detect the sexual orientation of a person using their faces. And just to show a little bit of this paper, this was the como é que fala? Esqueci. A média. This,
Composite.
the media.
It's called composite faces. It's an average face.
Is hi. Oh, sorry. The average, the average faces from the data set used, and we say we can see clearly that there are only white faces, and we have men with beards, men without beards, woman with makeup, and woman without makeup. And the result of this paper is almost the same thing. Gay people normally is grooming. There are no beard. And for a woman, if they have makeup, they are not lesbian. If they are not, they do not wear makeup, they they are lesbians. So it's a really bad paper.
It is. So, overgeneralization refers to when you think your work applies to broader scenarios. So, it's what I mentioned. I'm saying my paper is good for faces, but it's actually good for white faces. So, I'm overgeneralizing and saying my work is applied to faces as a general concept. And in this case, the author overgeneralizes by saying if this neural network is able of accurately detecting sexual orientation on this very little and very biased data set, then of course, on the real world out there, it will detect sexual orientation. So it relates to overfitting as well, because we might you all know that neural networks can overfit very easily, and we have to be careful that our model is not overfitted to a specific data set, to a specific distribution, and it's not going to work on the real world. That's why we have so many steps and so many partitioning of data and five-fold cross validation, because we're worried about overfitting. So we should also care about the overall distribution of our data, so we don't make the mistake of saying it will definitely work outside of this distribution. There's an entire domain, an entire research field dedicated to domain generalization. So be careful when you say that your work is good for faces or your work is good for whatever sexual orientation, because you're actually talking about the distribution of this specific data set you're working on. So be careful not to overgeneralize your conclusions on your papers. And oh, okay, this is very interesting. Aggregation bias. Sometimes overgeneralization can come from the mere fact we say that our system, it has 90% accuracy on classifying gender, which is the case of this image. And your system does not actually has a 90% accuracy. It has a 90% average accuracy. But if you disaggregate your data between subgroups, you're going to realize that for a specific subgroup, the accuracy is actually 68%. So sometimes overgeneralization can come from this aggregation bias. So when you think your model works for all subgroups of your data. So this is a very popular work called Gender Shades. It's from Joy Bulamwini and Timnit Gebru. This is a very interesting story that we're going to be talking about in the study cases section. Uh, they Nobody wanted to advise them to make this work, to research this, and they did it by themselves. And it's only one of the most popular works nowadays talking about bias in machine learning models. So the gender shades, they did one simple thing: disaggregate data between subgroups divided by gender and divided by skin type. And they realized for dark females, this, I think this is IBM, I'm not sure, we're going to talk a little bit more in the study case, but let's say it's IBM, that IBM said it had 90% accuracy on gender classification, but for dark females it had 68% accuracy, and for lighter males it's actually 100% accuracy. So this aggregation bias is when you say my model is 90% accurate, and it's not really if you think about subgroups on your data. And this is the last one, right? Yes. So would you like to okay. So racial bias and historical bias. I decided to put both of them here because we're all very familiar with racial bias as a concept. It talks about harming a specific group based on race. So a black person suffers more prejudice than a white person, and this also happens on machine learning models. So from data collection to models to results to deployment, racial bias is always there. So this is a case of a fairness of classifiers across skin tones in dermatology. And this is only an analysis of benchmarks of data sets that everyone uses to classify skin lesions. And it says that most of the image, the vast majority of images are of light skin. And an important aspect here is that you might say, but this represents the real world because most skin lesions happen on white people. But if you think about when you're developing a model, you cannot disregard a minority group. So even if the research actually portrays the real world, the outcome may still disfavor specific groups. That's the main thing you should take away from it. Because even if skin lesions affect more light skinned people, you cannot disregard dark skinned people, which actually have a higher mortality rate than light skinned people. So this is just that so that you look at your data set and understand the bias, the racial bias in there. And historical bias, it was introduced in this paper. I don't know if you noticed that sometimes we mention this paper on some of the bias. It was introduced on this paper as a generalization of racial bias for other forms of historical bias in society. So if you think about sexual orientation, which we just mentioned, if the majority of the data set is heterosexual people or cisgender people, this is historical bias as well. If you think about socioeconomic status, if you think about rich people and poor people, this might involve historical bias as well. So we can see all these toy examples of providing credit or not, hiring a person or not. Everything involves historical bias, which societal stereotypes that always come with the data.
One interesting thing on the historical bias, the compass that we mentioned earlier, it was yes, it was. It had racial bias and historical bias, mainly when we talk about poor regions of the felonies too. The more poor the person, the more the high risk was. Uh, the risk was higher. The
On the
more poor the people.
classification.
Yes, on the classification.
Yeah. And finally, an addition we made to this presentation is learning bias, because sometimes our decisions on the algorithm may lead to biases. So this is a great reading. Moving beyond algorithmic bias is a data problem. So it talks a little bit about that bias is not only in the data, it might also be on the constraint you choose for your model, on the loss function you choose. It might be even on the neural network you choose, right? The pre-trained model you choose. And this is so you think about the biases in the learning process. And this is a very interesting example. A very popular field right now is optimizing for privacy. So when you have a private data set, you want to optimize for privacy such that the private data does not leak somehow in your model. And this paper talks about how optimizing for privacy actually disfavor minority groups. and not only society minorities. Like if you have a subgroup of your data that is not part of the more dense distribution, this subgroup will be almost nulled on the model, will not have the same impact on the learning process. Your model is not gonna model properly the subgroup on your distribution. So this is bias introduced by a decision in the learning process. I choose to optimize by privacy, and I end up disfavoring a subgroup of my data. And it's something we should be paying attention as well. And just so we close the first part of this tutorial, you should be thinking about bias throughout the entire process of machine learning. And some of the bias are cognitive. It means are human biases, biases we as human have. For instance, racial bias, historical bias, expectation bias, confirmation bias, and they can happen in every step of the way. But you have biases that are more specific to some of the steps. For instance, sample bias is closely related to data collection and annotation and so on. Measurement bias refers to data as well. Learning bias, we're only talking about the algorithm. Evaluation bias, of course, is the results, the evaluation process, and so on. And we should be thinking about all these kinds of biases throughout the machine learning pipeline to make sure we're not how can I say that? We're not encouraging. No, that's not what I mean. We're not letting biases go forward. We're not letting them pass unnoticed in our work. And this is our break right now before we move to study cases. Do you want to say anything before we leave to get a cup of
I
coffee?
Yes, get a cup of coffee, a little bit of water, and we just to summarize a little bit. I think that what we want to say when we show this everything has a bias is that this is not a work only on deployment, only for the final user. The final user cannot work with a model that's already biased or data that is already biased. We have to remember that when we talk about machine learning, we talk about garbage in, garbage out. So we cannot let this responsibility go just for the final user. We have to be aware of it when we are doing our work too. And
And we
break.
can move for the break right now.
hello again.
Hello. I just want to say thank you for. Let me read his name. Leandro. He said he's definitely going to be using this tutorial on his classes, and I thank you for the compliment. And Natalia also said, "How was this published?" And I'm guessing she's talking about this one here. No, this which
The
one? That one. I'm
this one.
guessing. I don't know. But I ask myself the same question every
Yes.
day. I don't know how is this published. And I look several times to see if the journal is somehow worse than he was at the time. And no, it's still a good journal in the field of psychology. Okay, so now let's move to study cases. And this is going to be, I think, more interesting because we get to see some of the systems, some of the algorithms, and understand a little bit better what went wrong. And I don't know, it's more interesting. So let's start with pulse because it's a very interesting case of the difference it makes when you make your algorithm widely available. And so the author, and I congratulate him on that. That's not a critic at all. He, I'm sorry, someone, someone ring the doorbell here. I'm gonna try to speak, and if it's too bad, you can mention in the comments. But the author, he released the system, and he tweeted about it, and he said, "Here, there's the code. There is a runnable, an easy to run code in Collab. If you don't know Collab, I'm gonna open it here. Okay, so he released his algorithm in a way which I didn't know was possible. Actually, this is when I learned this was possible. So he released in a way that you only hit play and you can run with 0 lines of code, right? So in here, he's explaining step by step. So you need a picture of a face that is aligned and centered and cropped. And if you have one of such pictures, you can upload it here. If you don't, there is a system where you can crop your images. So it's very easy to use. You don't have to be a computer scientist, right? So people did. People started testing the system. And if you remember from the first part of our talk, Pulse is a system that performs image upsampling. So if you upload a picture, it has to be a low quality picture. It will attempt to generate an HD version of this picture. And this is a very important word. It will hallucinate. The author mentions the word hallucinate, a face that matches the low resolution counterpart. And why is this an important word? Because if it will hallucinate a picture, if you ever worked with generative models, you know that it's gonna try to build a face from the data distribution, right? It's a very rude way of putting it, but it will generate a face within the data distribution. So if it's hallucinating a face, it depends strongly on the distribution of data and the constraints the author puts on this distribution. So let's upload a picture here. I'm gonna try to crop the image because I had this on my computer, but my computer stopped working. So it's gonna take me a little while to adjust. So this is a picture that one of the Twitter commenters chose to highlight the fact that the system is performing this blackface, this very how do I say this, prejudice action. I Not sure it's gonna work because it's not aligned. I apologize for that, but I had this aligned photo on my computer. We can try with our. I think it's gonna be much better because this is already aligned. It's gonna work better. If you want, you can talk a little bit more while I download the photo.
Okay, we are,
I
and if
apologize.
those slides will be available to you, so you can test yourself with your own images. I think it will be a great idea.
Experiment.
The
Uh-huh.
it's a great experiment. Now we are going to use our advisor, our head of of lab, just
Yes.
a little bit. Yes, I think now it's okay.
I think it's gonna work. Yes.
And it's important to say that the paper as well is really interesting. The model is really interesting. The proposed method works very well with white
White faces.
faces. Yes, and that's all the thing we want
Okay.
to highlight here.
So
I think it's okay,
yes, let me
maybe.
start
Okay.
again because the dogs were barking and it was terrible to talk. So, given a low resolution image, Face Depixelizer searches the output of a generative model for high resolution images that are perceptually realistic and downscale correctly. So, everything is okay about this paper considering the assumptions it proposes. So, I'm going to give you a perceptually realistic image, high resolution image, and it's going to downscale correctly. This is questionable in a sense, but okay. It's a good paper. The images for the time of the paper, they were actually great. It was great, better than previous methods. But the problem with generative models is that they depend on data. So let's play it here. You're not going to see any code whatsoever, right? Because this is a great way of releasing stuff to the public. You can adjust settings without a single line of code here. And I think this is amazing. Honestly, I congratulate the author on doing that. But by doing that, he encouraged people to run his model as well, and people did, and people found out it was it was biased towards white faces. So while the model runs, it's going to take just a few seconds. This is some of the results it outputs. So this is Virginia up here.
Just
This,
on full screen, it's a little difficult
yeah,
to
yeah, no,
watch.
because I'm gonna be
Okay.
changing. Yeah, sorry.
Thank you.
Let me. That's the one. Is that the one? No.
No.
Para onde vai? É para downloads? Quando. Sorry.
Yes.
That's the one. Aligned, cropped as the algorithm requires. Okay, so now I can full screen while the model runs. So those are some of the outputs. As you can see, this is the one I intended to show you, but I would have to align it here, open Photoshop, and it would be a nightmare. So unfortunately, you can run this at your house later. And this is the result for the image on the left. Some Twitter commenter found out it was performing blackface. And as I said, we tested on several pictures. So this is Virginia. And the model chooses to drop the glasses because celeb faces doesn't have that much samples with glasses. And of course, model choices will affect how likely the generative model will generate glasses. The same goes for my picture. I have this African heritage, which makes me have this little baby hair on the front of my head. And the model thought it would actually be a bang, right? This straight hair over my head, and I'm somehow blonde and have blue eyes, and I'm this white stereotype. And the same goes for our advisor. He is brown as well. He has a Brazilian heritage, right? So he's not white, but he's not that dark as well. And he turns into this stereotype of white male. The same goes for Asian people. They are whitewashed as well, and so on and so forth. So if we take a look at the model, which we just ran like right in front of you, so this is the result. It generates this white version of the image. I'm trying to, yeah, that's better. It generates from any image you try to put. I honestly would like to see the system generating a brown person. I could not make it do so. But this is always, the person will always have something like blue eyes, a blonde hair, a white face. It's very interesting. Try putting like bald people. It would adhere to bald people, drop glasses, and all kinds of biases that to this day I wonder how the author did not catch. Because it's just a matter of having a bald friend, right? That would test your system, or a dark skinned friend that would say, can I run my picture on your model? And how is it possible that the author didn't notice? I don't know. But of course, the data set is mostly white people, mostly stereotypical European people and North American people. So yeah, that's Pulse. And if you check the Twitter thread, it's linked in the paper, the original paper. If you check the Twitter thread, people tested all kinds of pictures. People even went as far as putting characters from video games like Super Mario and all kinds of faces. And the system always generates a white person, and which is incredible. But as I said, congratulations on this work. They are photorealistic, of course. They downscale somewhat correctly, and the author decided to release it to the public, which I think we should do as much as we can. So there's good stuff and bad stuff. Later, the author released a model card, which should be done before any problems happen. It should be done anytime you train a machine learning model. And in this model card, we'll talk a little bit about model cards in the bias section. He mentions intended use for the system. He mentions ethical considerations. He mentions the training data, the metrics, why he chose the metrics. It's just a thought experiment on why did you train this model? With what intentions? Did you consider the ethical impact of releasing such model to the world? Because the same way he released a model that upsamples images of faces, the psychology paper could release an algorithm that detects sexual orientation, right? We have this ability to just release algorithms and models, and we should ask ourselves, have we analyzed the ethical impact of such a model being released? So in this model card, he mentions evaluation bias, as we said earlier, but there's more to it than evaluation bias, right? Because he suffers from evaluation bias because of the benchmark, because of celeb faces. But we can also consider the sample bias of available images from celebrities which he uses. We can think about sample bias in the sense that most photos on search engines are from white people and stereotypical faces. We can think about learning bias because, of course, had he made different choices, different learning algorithms, different constraints, different metrics, maybe the system wouldn't be so uh, strongly associated with white faces. Of course, there are methods that work with celeb faces and are still able to generate dark skinned people, Asian people, because they exist on the database, so they are on the distribution. And of course, racial bias, because, well, in many stages of the process, from the fact that the author didn't notice that the system was biased to the data set itself.
And it's interesting to comment that the model card was only released after the all the confusion that Twitter has made, the
Yes.
tweet has made. So it will be released, and everything was the same if someone wasn't on tweeting wasn't tweeting the results of polls.
Can you introduce gender shades? I need a second here.
Yes. So now we are talking about gender shades. That's the work of John. Oh, sorry.
Sorry. Yeah,
It's a work of. Oh, yes.
go on, go
Just.
on.
Oh, sorry. It's a work of Boalamini and Chimit Gebro that Camila just said that uh, nobody wants to work with them in this subject, and they work by themselves anyway. And the idea is to analyze all these available face detectors and face classificators that are for from big techs like Microsoft,
Is gender
IBM.
classification.
Gender classification, sorry, gender classification based on the face, gender classification from these big tech companies. And the idea was really simple quotes that when we talk about the overall accuracy, it was very good detectors, and they say what's female, what's male. But when we start to analyze by subgroups, by analyzing, I think they use the Fitzpatrick measure for skin tone. Yes,
Yes, and dermatology is approved, and it was
yes.
very good work.
And they started to see that the more white the face, the more the classification was good. And as we start to darken the skin, the results were very poor. We say that on IBM that said that was 90%, almost 90% of accuracy. When we talk about black woman with dark toned skin, it was only 46%. It's below random. So it was
This
very
is the
poor.
error. So
They
it's
are
actually 54%.
54%. It's almost random. Almost random. Yes.
So I recommend, that's why I put the link here. I recommend you visit the site because it's a uh, very well done, I would say. This explains how the research was conducted, and it talks about the data set, which was people from parliaments from different countries, so African countries and European countries, just to make sure that the database would contain several shades of skin types. And they selected from several countries, and they divided into skin types, lighter skin and dark skin, to make sure it was balanced. They oh, and this is important. Dermatologists were the ones that classified skin types. So it's not an opinion like what is dark and what is light. And they measured IBM Watson, Face Plus Plus, and which one? Yeah, Face Plus Plus, IBM Watson, and Microsoft Cognitive Services. And they found that the overall accuracy was around 90%, but actually, if you divide into subgroups, the gap reaches 30%, uh, the 30 percentage points between subgroups. So it's interesting to see that by disaggregating the accuracy, you get such different results. And it says a lot about the priorities given, right? So this is a very well done website. It explains the project in a way that anyone can understand, even outside the computer science community. And it goes as an incentive that if you have a model that is relevant to the public, that you do something like that as well. Let me go back. Oh, so just mentioning the overgeneralization and aggregation bias. This is the things that gender shades try to highlight. By disaggregating measures, it reveals this aggregation bias on the average accuracy and the overgeneralization of those methods by saying they are 90% accurate on detecting gender.
And we can see also the evaluation bias here, because the normally we just use the overall accuracy, but here we can say that that's not the point. Here it doesn't
Yes.
work very well.
Yes. And this is another seminar, another talk that I highly recommend you watch. This is where I got the previous slide. And this is the one of the authors, Tim Neat, talking about the paper. She talks a lot about her work in general, like other papers she worked on, her activity in Black AI, for instance. And it's a very interesting talk about the hierarchy of knowledge. It's a very strong title, I think, because it talks about what kinds of studies are conducted, who decides what studies will be conducted. Is mostly people in power, right? They decide what works will be studied and what's not going to be studied. And it's very interesting. And this is what I mentioned earlier, that Joy Bulamwini did gender shades when she was a master's student at MIT, and Timnit advised her as a PhD at Stanford. And she says it's unusual for two students to write a paper. The reason was people did not understand why we were doing it, what exactly was the contribution, and they would ask, what is the algorithm? So this is a very personal thing for me, because I decided to also look at ethics and the AI, because that's the reaction I also got when I started wondering, like, shouldn't we be asking different questions? Shouldn't we be worrying about how is it going to be applied, deployed in the world? And they would say, like, what's the point? There's no contribution here. And this is very interesting, because ethics should be a concern if we're working with humans. We see it on biology, we see it on medicine, we see it on social science. We see in all kinds of fields except computer science. And we're increasingly working with human-centered data. And if we're working on human data, we should be concerned about ethics. And yes, it is a contribution to analyze and evaluate biases on algorithms. So try to think from the perspective of someone that belongs to a minority group. how would she feel if she, I don't know, playfully wants to test this new algorithm and she notices, okay, so I'm now white, my hair is now straight. So how do you think a person would feel? So it is a contribution in the computer science field, and that's what Joy and Gebru were trying to say, and no one wanted to advise them because, well, what is the algorithm after all? So it's a very interesting. I even highlighted the section on the talk when she says that, because this is from this point forward she talks a lot more about gender shades, and if you want to get to know the work of gender shades, that's the point of the presentation.
And if you want to know a little bit more about Bolamini work, she just finished her PhD in the beginning of the month, and also she's one of the the authors of the Netflix documentary that I Coded Bias.
Coded bias, great.
Coded Bias. She's one of the authors of this this documentary, and it is very very powerful.
Yes, it talks a little bit more about how these face recognition models that we're working on, they are already being used to harass people, to harm people. And we should be paying attention to that because we are responsible for releasing such models and concluding that they're so great and so accurate and so ready to be used, right? Okay, so just generalizing the idea of racial bias, that's the whole point of this part of this study case. When we develop a machine learning model that is biased and we say it's ready for use, and big tech companies, they also think it's ready to use, we end up with tools that end up harming and harassing minorities for years now, because we have, for instance, Google Photos, which is the pair of images we're showing here. In 2015, Google Photos, I don't know if you had this experience, but Google Photos, it makes automatic albums like graduation, bikes, and toasts. And it made this automatic album called Gorillas with the owner of the phone and their friends, her friends. So she tweeted, I don't know if it's tweeted or Facebook did, I don't know. She posted it saying, "What the fuck, we're not gorillas." That's her quote. And this was very hurtful for her. And we fast forward to 3 years after what happened, and the solution so far is still to this day, it works like that. If you search for gorillas on Google Photos, it returns nothing, even if you have gorillas on your phone. So this, I'm not sure. I think it's ProPublica as well, but they
Algorithm
made,
watch.
oh sorry,
Algorithm
Algorithm
watch.
Watch. They performed this several experiments with Apple Photos and Google Photos, downloading several images of gorillas, making albums of gorillas. And if you search Google Photos for gorillas, it won't return anything whatsoever. This is a message, a powerful message that they don't know how to fix, or they don't care maybe to fix that. But this is the result of releasing biased models and big tech companies started using. And it's not just big tech. If you think about startups and small companies as well, they're going to look for the state of the art in face recognition, in object recognition. And the state of the art in object recognition is going to be the models we release to the public, right? And this goes to, as I said, to this day, Algorithm Watch still is performing studies with Google Photos and Apple Photos and big tech companies, and showing that this is a very strong and harmful example. There is this picture of a man holding a hand thermometer we're all in a pandemic still, and hand thermometers, they're being used right now. And Google Photos tagged the thermometer as a gun. And if you do this poor job of painting the hand in a beige, a white shade, skin white shade, it starts recognizing as a tool, as a monocular, whatever a monocular is, but it's not a gun anymore. And this is a very harmful example of how automatic systems can tag a black person with a random tool on on his hand and tag it as a gun, and from this moment on, this is a dangerous person, call the police, and ta ta ta. And the same goes for Apple Photos. This is a very recent example. Apple Photos, this is German for animal. Tier is German for animal. If you look for animal in Apple Photos, it returned this drawing, this cartoon of two black people in this loving interaction, whatever. And the same experiment was performed. They painted the drawing in a skin white shade, and it was a better job of painting the skin. It was like a new cartoon, and it stopped returning when you look for animals. They tested with several cartoons and drawings, and Google Photos and Apple Photos would understand black cartoons as animals. So, yeah.
Yes.
And the lack of
And one,
transparency. Oh, okay, go on.
no, just for the thermometer image. After Algorithm Watch released
Oh, yes.
this text, they performed again the same test, and the word gun was not available anymore. It was just that. It's just
Hand.
like the gorilla example. It's now just hand. There is no gun, but it's just the
Or
gorilla example
monocular. There's no
or
monocular as
monocle.
well. There's
It's
nothing.
just a hand.
Yes.
Yes.
So yeah, we'll reach a point where there's not going to be labels anymore because they're going to drop label after label and
Yes.
not going to fix the actual problem.
Yes, and that's what you were going to say, that the lack of a transparency just does not
Yes.
allow us to proper evaluation
We
anything.
cannot
We don't
say
know
if,
where is the source of the
yeah,
bias.
we don't know if it's sample bias, if it's learning bias. We don't know anything because big tech companies do not release their models, right? But we can guess that the same that goes in academic research also happens in big tech companies, which is why we're doing this entire talk. So, compass, and we're not talking anymore about racial bias, is more of historical bias. We mentioned earlier how it tags Black people as higher risks than white people. But now we're going to try to understand why it does that. Like, what happened, at which point it became a biased system. So, this is James Rivelli, the white man here, and he had this huge criminal record. He was convicted of aggravated assault, multiple thefts, drug trafficking. He was arrested 2 times before that, and when he was interviewed by ProPublica, he said, "What? My risk is 3." And he was arrested by shoplifting. It's a small crime, right? But he had this huge background, and he was low risk, and he didn't understand how he was so low risk. And on the right, you have Robert Cannon, a poor black teen, early adult, and he didn't have as much of a long record as Rivelli had, and he was medium risk. He was 6 in risk. And what happened is it only because he's black? Is it a racist system? No, ProPublica says is a little more than that. It's It happened when the authors decided what data to collect. So the input for the system is a questionnaire. The questionnaire is available. ProPublica made it available. You can look at it. And all features are proxies for socioeconomic status. So it asks, are your parents divorced? Do you live in a poor neighborhood? Was any friend of yours ever arrested? And those are all questions that a person in a lower socioeconomic status will probably answer yes, because, well, those are people living in conditions where the state does not support them. They live in poor neighborhoods, crime rates are higher, and so on and so forth. So, of course, he met someone that went to jail. His neighborhood has more crimes, and it's not the person's fault, right? It's a whole system in society that leads to the person answering yes to those questions. So James Ravelli is a white person living in a white neighborhood, and he's not going to answer yes to any of those questions. And because of that, even though he has this long file of previous arrests and drug trafficking, he's a low risk because he has more stability. But you see, the choice of deciding that because a person lives in a bad neighborhood, suddenly you should watch out for this person. This is a higher risk person. You're only abusing a person that's already abused by society. So this is a very strong case of measurement bias, because you're measuring features that will introduce social bias, will introduce historical bias into the system. And you also have on deployment confirmation bias and automation bias, because as we said, people were deciding the system was more right than their own decisions. So in some cases, you would have racist people looking at the results from the system and saying, of course, this is a high risk person. So this would be confirmation bias along with automation bias. And you have judges saying, well, if the system is saying he's a high risk, I should reconsider. This is automation bias again. So when we decide to select features, if we don't have this ethical perspective, this point of view, that what does it mean to ask if a person is from a poor neighborhood? Is it her fault that she's from a poor neighborhood? And if you start thinking about it from an ethical perspective, you understand how you are abusing a person that's already abused by society.
And we really recommend you to read this ProPublica study. It's available on the slides. We already put them in the chat. They evaluate more than 7,000 arrested people in
Cases, yeah.
Florida. Yes, so it was for 2 years, and this study. So it's a really, really, really interesting text to read.
Yes, and risk assessment tools are still working on the United States to
Yes.
this day. So this is a current issue, although this specific analysis is a little bit old. So,
And now,
this is. I know this is a borderline case of bias, but I put it here for a reason, because we're gonna see that we're not that far away from this terrible type of bias of this sexual orientation detection. So this is what the author did. He evaluated this neural network on pictures from online dating sites of people self-reporting as gays or heterosexuals. So if you get the author experimented with humans judging those pictures, and the accuracy was about random, which for me it's what should be. It should be random, because you cannot tell sexuality from people's faces. So it's little above random, 50%, for humans, and the algorithm reached 90% for men and 83%, I think, for women. And the author concludes that we show that faces contain much more information about sexual orientation that can be perceived and interpreted by the human brain. So machines are better than humans at detecting sexuality. So would you like to make the honors?
And I think that there's so much problem with this paper, but the main point is that we have a lot of bias here in everything. The authors tries to use some kind of prenatal hormone that makes your face seem much more gay or not. So they try. It's really overgeneralization, but a little bit of confirmation bias too, because they
Yes.
try to put this result in the I believe in that, so I need to my results to show that. So the data source they use is it was just only dating sites on Facebook, and they was just openly gay subjects that said that on this online dating. The sexuality was only binary. Okay, it was only gay or not, lesbian or not, and we start to see some more than that, more than just a binary sexuality, and that we know that isn't like this. The subjects were all Caucasian and all cisgender. So the appearance is just female, normal,
Stereotypical.
stereotypical appearance. And Margaret Mitchell has a really nice text on that on towards in data science, that they analyzed this paper and show that the paper is really well to detect eyelashes, glasses, and beard and mustache. They are good at this. They are not good at to
Sexuality.
to find the sexuality of a person. So, but again, it's it's the thing that when we release this algorithm and release these solutions to everyone, we had to take care of what we are showing them. If someone on psychology field says, oh, this is a neural network that finds faces and I can use it in every aspect of it. No, it's not quite like this. It's a really bad problem when we use science just to justify our prejudice. And this
Yeah.
is
And
just
when I say we're not much far from it, I know you're going to say this is bad research, this is bad work, but think about how much we try to interpret the results from our neural networks, our machine learning models. Uh, we should have in mind that those are machines to find correlation in data, and they will hang on to any specific little aspect of the image to try to find this correlation that you're saying it exists. So we're assuming there is a correlation, and we're using these great machines to find those correlations. However they understand, they see possible. So when we interpret the results, we should be careful not to say there is causation relationship, that there is this complies with this theory, it refers to that confirmation, that the conclusion, because all those neural networks are saying is that there exists a correlation. It might not be what you thought it would be, but there exists any correlation. In this case, people were quick to understand that the author chose openly gay subjects, which means they present themselves in online dating sites and Facebook. And when we say Facebook, it's not Facebook as a whole, but also communities, dating communities on Facebook. So people were trying to find a partner. So they would present themselves in a specific way to attract partners, right? So they would put makeup on, or shave, or I don't know. Yeah, they would present themselves in a specific way to attract the gender that they were attracted. So people were quick to find out that that's why you have straight women all wearing makeup, or you have gay men positioning themselves in a specific way. And the author somehow expands this conclusion to saying that the shape of your head would tell something about your sexuality. So we should be careful. So it's measurement bias because the author decides to measure the shape of someone's head to associate it with sexuality. It's selection bias because the author chooses online dating sites which are biased towards presentation. It's sample bias because online dating sites will have this completely biased sample, and it's overgeneralization because the author concludes it's because of the shape of the head and it's prenatal hormones and so on and so forth. And now for automation bias in data collection. And there's a reason why I put those examples one after the other, because we look at this paper and we're like, yeah, he's trying to detect sexual orientation from images. But we're going to see that by automating bias, maybe we're not even noticing that we're doing the same. We're trying to detect aspects that are not imageable in data sets as well. So this again is the paper Large Image Data Sets, a Pyrrhic Win for Computer Vision. And it talks a lot about the WordNet effect. WordNet is basically a network, a lexical database of relationship between words. So this is, I didn't put the link to this website, but you can look for visualizing WordNet and you can enter any word you'd like. I enter the word cat and it will show, I think it's 3 levels of relationship in the lexical database. So cat refers to tomography, computerized tomography, CT. People call it CAT scan, but it also refers to felines, to feline and domestic cats, house cats, and leopards, lions, and that there's all these relationships on the lexical database. So what people do to automate queries is, I want to look for people, person photos. So I go on WordNet and I see all these related words to person, and I automatically develop 100 of queries. Other than person, like person, man, child, woman. I have all these words that are related to the word person, and automatically I have 100 queries that I can look in search engines and build my data set automatically. I have millions of images just by entering the word person on this automatic method. So that's what people did to build a tiny images data set and to build ImageNet. They used the relationship, the database that WordNet builds. So for ImageNet, this study found a lot of misogynistic, consent violating transgressions, such as upskirt pictures, like someone took a picture of, I don't know how to would you like to?
I'm trying to select the word here to not be so terrible, but like someone with the camera and an unconsensual picture,
Non-consensual.
non-consensual picture of someone's panties, maybe
Yes,
something like
and
this.
exposed private parts, so naked people, and voyeur photography, so someone took a picture without being noticed of someone at the beach doing something. And you had, not anymore, ImageNet already fixed this little part, but you had 2,832 classes on the person subtree. And some of those classes were transvestite, bad person, fornicatress, orphan, mama's boy, and enchantress. It's some of those classes. So by using the lexical database of WordNet, they ended up mapping these labels that are not imageable. And if you were so shocked by someone trying to classify sexuality, you know now that ImageNet initially had all those labels, automatic labels of stuff as bad or worse than sexual orientation. And for 80 million tiny images dataset was even worse because they found harmful, abusive labels that I am having trouble mentioning here. But you can look at the slides and you can see the situation of tiny images, and you know that tiny images was removed. And but if I'm not mistaken, there are still data sets that use samples from tiny images. So we should check when we're using an image data set, where does it come from? What kind of samples? What is the data collection process? Because I'm now very what is the word, skeptical. I'm very skeptical when I see automatic data collection, because if you want to build a large scale data set, obviously you're not going to have the power, the sufficient labor, let's say, to inspect the database. So something wrong is probably gonna go unnoticed. And with
And just to show a little bit more of those harmful and biased searches, it's not just WordNet, but the WordNet effect when we are choosing to our samples for a data set. We are on a search engine, we see already that there are a lot of stereotypes when we are searching. Here, we saw that on ImageNet labels, we had things like competent man and warm woman.
this is a
And
different data set.
oh, sorry.
But go on, go on.
Uh, but we don't have competent woman like this. We can see when we search for doctors on Google search. It's a good example too. When we search for doctors, we just receive white male persons, just white male doctors. There is no woman doctor, there is no black doctor, and we cannot rely on these kind of data sets and in forms of created data set that are already biased on the
Collection.
from the first and from the first
No.
thing.
This is a link that is worth clicking as well. This is, I think Margaret Mitchell was part of this research. This is measuring diversity. And the authors, they mention, like, consider that diversity is measured in squares and different colors of squares and sizes of squares. How do you reach a diversity search result, let's say? So you can play around and see that sometimes it's very difficult to find the diversity. I think it's the third one. I struggled a lot to find like a diverse set of squares here. And it goes on saying that diversity is difficult to reach, and it's okay. We have to work on it. So this is like, you can try reaching different levels of diversity here. You can see diversity as metrics, and this is very interesting. So how do you apply this to search engines in a way that it will return socially acceptable results. So this is two examples. In one side, you have all male doctors, but you have blue clothes, green clothes, white clothes. Is this diverse? Or is all doctors in white clothes, but divided between male and female? Is it better? As for diversity, depends on the targets you set, right? So this is an example from I don't know where I think it's some stock footage of construction workers. So women are sexualized and represented in a specific way when you search for a construction worker, and men are more real to real world, like it's real world images of construction men. And this says a lot about the available samples. It says a lot about what search engines are returning. And this is an interesting reading to think about diversity as metrics and as something you have to define. Like, what am I looking for when I say that I want to reach diversity? This is something we should think about. So those are a couple of papers that we also recommend about how search engines return biased results. So you have, when you look for occupations, as Virginia was saying, doctors are always male, hairdressers are all female, and this is searching adjectives like competent, warm, nice, lovely, professional. And search engines, they are biased towards gender, so they're both referring to gender bias in search engines. And those are the cases we brought for study cases. And now we're going to go for another 10-minute break so we can finish with debiasing and discussion. Do we have to call someone?
Yes, we have one question. I don't know if Sandra will be here. We are finishing this part of the talk. I don't know.
This is an interesting
Maybe
question.
I can read.
Okay, go on.
Yeah. Okay. There she are.
Okay, thank you.
Oh.
Bye.
Okay. Sandra, you asked. Sandra, where are you?
Oh, okay, I can do nothing. I'm here again. So, thank you so much. We have one question from audience. The question is from Douglas Oliveira. First, I'll read that. Thank you both for this great tutorial. It's a must see. I agree with that. I totally agree. The question is: Do you know of any action from conference journal in order to alleviate this bias regarding the publications?
I would say new conferences are arising, such as FACT, which fairness, responsibility, and some very specific people are also proposing that, for instance, conferences start checking data sets before accepting them. They start requesting the data set before accepting them. But I haven't seen any actual interference or any actual action towards solving bias issues. Oh, okay.
Sorry, but I have the reason for that. Since last year, I think I don't know if it's last year or this year, the NeoRIPS conference. Before you send your paper, you have to fill a form because we have to know before the publication if the paper passed from the checklist from ethical perspective. So
This is
yeah, we check
nice.
that. Yeah, it's very nice. Yeah.
Notips is a great example because they host fact, right? I don't know, the template is the same, but they I do know they host Black and AI.
Yeah.
It's within Notips, so there's a lot of good people involved. So I would
I
expect
think
such
the
a
I think the black and AI start in the ribs.
okay.
But yeah, yeah. I'm not sure, but I think. Yeah.
But there are a lot of workshops. I saw CVPR this year with a workshop on fairness. So this
Yeah.
is something, although it's not an ethical form, it should exist, but they're hosting workshops, which is nice.
Yeah. I don't know if we have more questions.
There's one
Yeah.
about skin
Yeah.
tone. It's for
Yeah.
you.
For
Yeah,
me?
it's for Sandra this.
No,
Skin tone
no, no.
augmentation. Okay.
So I was wondering, perform skin tone augmentation to deal with low representative in-face datasets can be seen as a kind of blackface.
I think so. I wouldn't
No,
do that.
please, please, go.
I I personally wouldn't do that. I think so. We should. I think we should worry a little bit more about handling the types of models we train because we can augment the data set by replicating samples and rotating samples and all kinds of interferences. But I don't think blackface is the way. You wouldn't want to generate such images. No.
And you have other forms to deal with this. We will talk a little bit more on the biasing, but if you have this representative face that is, well, 90% is white and just 10% is black, you can perform a disaggregate accuracy. So you evaluate your data set in a different form than, well,
You can have
do not do blackface.
disaggregated losses. You can have all
Yes.
kinds of aspects introduced other than skin augmentation. I thought it was about skin lesions. That's why I said it was for you.
Yes.
For skin lesion, I'm sure that will not work because the patterns are different. So we need the true data, not something like augmentation.
Oh, did you have any experience with
Yes.
synthetic data?
No,
Okay.
because I didn't try because I know the part is different. So
Okay.
if I think about trying that, I it's just to show that okay,
It
it's not
doesn't work.
working. Yeah,
Okay.
yeah. Okay.
Okay.
So I think we can go to the break now, and we'll be back in 10 minutes.
Okay.
Thank you.
And we are back.
Welcome back, everyone.
So, for the last part of this talk, we are going to try to show you some solutions for debiasing. As we saw, that when we talk about machine learning pipeline, we are talking about a machine learning bias pipeline. Every step of the way can be biased from the data collection through the algorithm, through to the deployment. So we have to take care as we are constructing human things for humans. So you have human choices all the way. So we can so when we are talking about debiasing, we do not have a silver bullet. We already saw that there are a lot of types of bias. There are a lot of solutions that we can take, but what we know that is an ongoing process. So you have a lot of steps that we have several steps that we can try to, if not eliminate bias, but try to mitigate them throughout the process. And if you start from the early stages of a project, it's much better. We will lead to much better solutions, as we already saw. We already spoke here that when we talk about machine learning, we are talking about garbage in, garbage out. So you try to mitigate this garbage that we are putting on our systems. So when we start from the machine learning pipeline, we can start about talking about the data. So the first step that we have to take care is ensure that your research team, your data science, your labelers are diverse. A lot of studies are showing now that teams that are diverse leads to better solutions. And think a little bit about posts. If there was someone bald in the team, at least it will show this. So this is a really important thing. We have to have diversity on every step of the way. And when possible, of course, try to combine inputs from multiple sources. That is, maybe it can resonate a little bit with what R. Souza, I don't know his name, R. Souza was talking about data augmentation and everything. When we have multiple sources, maybe we can have a little bit more diversity on our data set. Of course, we have also to ask someone on the field to try to review and collect and annotate your data. Maybe when our main article about sex orientation, if the author just asked someone on the field and, well, what I'm doing, it's okay, and someone could say no,
No.
please, no. So this is very important. That way we can at least mitigate our measurement bias, sample bias, recall bias, at least mitigate. Yes, it's utopic to think that we can solve all the problems, but at least mitigate them. And as we talk about labels, this is very interesting. We show a work about it. We have to have clear guidelines for the data labels. We have to have some kind of ground truth to them to follow. And it's a really interesting thing to have multipass annotation systems. That is, it's not just one bound box and it's over. No, we have to make a system to have steps and to have more than one labeler to provide the label we want.
And I want to highlight the aspect of domain expertise because At the end of this presentation, we're going to recommend some books for you to read. And one of the books talks about something the author called techno chauvinism, which is this belief that everything can be solved with technology. So we sometimes think that we as computer scientists, we can just try to develop an algorithm. Now that we have a machine learning and neural networks, we can just train those neural networks on anything we want. But that's not the case. For instance, trying to find sexual orientation from faces shouldn't even be attempted, right? Because it comes from mistaken assumptions. So this idea that we as computer scientists can just interfere with social science and biology and other sciences without consulting those people, those are wrong assumptions. We have to talk with people that study the issue so that we don't make bad choices along the way. So this is a very interesting example of the importance of training, thinking through a pipeline of labeling your data set, because this is the first step to prevent bias, right? You should think of guidelines to label your data that will prevent biases from passing, from staying on the database. So this is Google Open Images. Prior to version 6, it has 6 versions now. Open Images is a large-scale data set of images. And annotators were given labels from an automatic detection. So given an image, an automatic detection would say what objects there are in the image. And the labelers were instructed to select bounding boxes only for the classes on the leaves of label hierarchy. So we have this hierarchy. For instance, food is on the root, and you have seafood, vegetables, baked goods on the second level. On the third level, you have, for instance, shellfish within seafood, and then you reach like crab and shrimp as the leaves of the hierarchy. The same goes for people. You have person, under person you have body part, and you have woman, man, child, arms, legs, and so on. So this is the label hierarchy. And labelers were instructed to only provide labels on the leaves of the hierarchy, such that we have more specific labels, like more fine-grained, let's say, for the data set. So the most recent paper they released, they realized that for the person class and the subclasses, those instructions are very problematic because automatic solutions can be biased towards societal stereotypes. So those are 2 quotes from the paper, the one that detected the problem. So the first example is the marriage. So in traditional heterosexual European and US style wedding, the focus of the day is placed on the bride. So the white dress, the veil, and the automatic system would detect something like person and woman. So it wouldn't detect men. And the labeler was instructed to focus on the leaves of the hierarchy. So I would only label woman because it's below person, right? So I'm the labeler. I was instructed. I'm just doing my job. I would draw a bounding box around the bride because it's the woman. The same goes for the military picture. In the US, the majority of military personnel are male, a prior that is reinforced in the missing bounding box. So the automatic system sees a military clothes, and the automatic system would say it's a man. So person, man, and child, because there's a child in the picture. And this bias, this not detecting the woman on a military picture, leads the labeler to I will not annotate the bounding box on the woman because it's not on the leaf of the hierarchy. So for the person class, this kind of instruction led to reinforcing societal stereotypes such as marriage and military, and the dataset was therefore biased. So that's why they released version 6 of Open Images, focusing on the person subtree. So now they're going to annotate the person subtree with more care for those societal stereotypes and to add more labels and fill those gaps left by the first process of annotation. So we should pay attention to that. Why wouldn't they see, when they looked at the final result of the database, why did it take 5 versions of the database for them to notice that societal stereotypes were being reinforced on the data set? That's the thought process we are bringing up here. So, besides instructing the labelers, you should watch out for subjective concepts and inconsistent labeling. Sometimes your instructions are great. You did the best you could, but the data you're working on is highly subjective. It depends on the labeler. It depends on the background of the labeler, the culture I come from, what I'm accustomed to. So for instance, I forgot the name of the field. Oh my God. Sentiment analysis. So no, it's facial expression. Actually, it's facial expression. Facial expression classification is some of these subjective concepts we're talking about. So I can look at a face and I may think it's fear, and Virginia thinks it's disgust, and we disagree. We annotate differently, right? Is that because I wasn't properly instructed, or is that because this is a highly subjective concept and it depends on my worldview? So there is this paper that I recommend you read about inconsistently annotated data sets and how to deal with that. And this is a very interesting take. I was just talking with a friend of mine about how you should not focus on majority voting. Okay, if I have a disagreement between my labelers, I'm going to do majority voting and assign a single label to the picture. No, there are a lot of papers, and this is one of them from Google Research, saying that inconsistent labels, they are signals and not noise. So you should pay attention, because if labelers are disagreeing, maybe there's something to the image that is worth highlighting, some subjective concept, some ambiguity to the image, and you should pay attention instead of just doing majority voting and ignoring the opinion of, for instance, minorities. Because one of the findings from this paper, amazing paper, very recent, it was just released this month. One of the findings is that you can completely disregard minority views if you just consider majority voting. And they give an example of the Black perspective, because so few of the labelers were Black, and their views on a subjective concept was disregarded because of majority voting. So it's something we should pay attention as well.
Yes, and in other fields, this type of several labelers to be able to validate some samples are very, very, very important. Checkspert is one of the main uses data sets to. Sorry, the dog's biting me. Sorry. Checkspert is one of the main data sets. Yes, the main data sets for lung lung image and for um,
Lung
to
lesions.
find pneumonia lesions and everything. And the idea is that the validation samples is just the ones that there are a consensus between the labelers that are radiologist, of course, and this is very interesting to know that what is not a consensus here. Maybe this lesion is much more difficult to be annotated than others. So it's a very interesting paper to be read too.
Yeah, and the concept of multi-pass annotation is providing the same sample to multiple labelers so that you can see a more diverse view of that sample. And Checkspert is a very interesting data set because it has like 200,000 samples for training and 200 period for validation. So you have 200,000 training samples, but the difference is you have uncertainty in the training samples. You have disagreement between labelers, and this disagreement is modeled as uncertainty and not just majority voting to assign a single label, which would be bad for your model, for your final sorry, for your final model. So, okay, you're gonna have 200 samples for validation, and that's it, because that's the consensus we got, and the rest is uncertain training. And that's fine. That's better than poor labels, I guess.
Yes. And one of the main things also that we have to have on our data is know your data and make it available, because that's why we have some kind of problems like racial bias and historical bias, because when we test something on Celeb A, for example, and we just forget that it's just only white people there, it will be lead to poor results. So there is a very interesting work called Data Sheets for Data Sets from Timit Gebru et al. You may notice that Timit Gebru is in everything on this presentation. Her research is amazing. But Data Sheets for Data Sets is already on its 70th version on archive, I believe so. But the idea is to, when you are creating your data set, make sure that you make it transparent and make sure you have accountability on them. So it has some questions that you can answer about your data set, like what's the purpose of this data set? What's the motivation of it? Why are you constructing this? It's relevant in which field? What is the composition of this? This is very important because that's where you can put that, if it's diverse or not. For instance, how was the collection process? You just went on Google and type something and it's okay. So this is very important to know, that with this we can know, we can already know if there are some stereotypes problems on your data set. We can also tell about the labeling processing. What was the pre-processing? You had to, I don't know, cut the image, and we work only on 256 per 256 images. What are you going to? What are the use from this data set? This is also very important to show. And what kind of distribution you are thinking of. This is an open data set or it's a private data set. It's always important to know that. And of course, the work you do doesn't end when you release the paper. You have to have something about the maintenance of this data set. What's going on after this publishing? We are going to just finish, we are going to put some image. What's going on with this data set? So this is a very interesting work, and I believe it's a way to at least start to know what you're doing with your data and make it available to have transparency, to have accountability, and think about fairness. So maybe when we are answer these questions, you already are finding where your bias can be on this process, on this step?
And in the paper, we mentioned this unfinished work. It's from a workshop of CVPR, but it's not yet published, but it's available on YouTube and Google Drive. The author made it available. It's about how we think by releasing a data set, we can start this, we can stop worrying about it, but actually, no, because what if people try to add new labels to your data? What if people try to augment your data? Is it okay? Can you do that? Is it ethical? Depends on the data set you're choosing. Can I, for instance, assign, what is a good example, a data set of faces? Can I assign um, attractiveness, for instance? This is not recommendable because this is very subjective and probably biased towards a specific culture, right? So you should also pay attention to the next steps, to what people are doing to your data, in order to so that it remains ethical. And this is not the job, this is the most important part of this research, that it's on the paper, you can look at it. um, it's not about just the author, it's not the author's sole responsibility. It should also be the conference that allows it to be published. It should be the research community, it should be everyone paying attention to that data set, such that someone doesn't interpret it in a wrong way, doesn't use it in a wrong way. A simple example is the vast majority of data sets, human centered, they are only allowed for research purposes. But people seem to not understand and still use it for commercial purposes. And this should be inspected. We should pay attention to that, because we were the ones responsible for collecting the data and making it available. So we should track who's using, how is it being used. And it's a lot of work, of course, but if you just want to automate a collection and release it out there, well, you should really think, if you want to build a data set, or you just want to, I don't know, compromise people's identities, people's sensitive data, is it worth working with human-centered data set and following an ethical protocol? Or you just want to release it without a care? You have to think about that.
So what datasheet says that it's not just to mitigate data bias, but also think about ethical, legally, and to reflect a little bit about the fairness perspective inside your job. So it's everything that Camila said, that now we can think a little bit out of the box of just, I'm doing just a data set and okay, and problem with with someone else, the promise for someone else. So it's really important to start to think earlier, and
Yes.
when you are creating your data set. But sometimes just it's not even possible, of
Yeah.
course, because when we are working with computer vision models, we mainly are work with transfer learning on pre-trained models, so the data isn't mine. I can just not, okay, my data is like this, I work with this, and I cannot change the data set I'm working. And even so, I have to use some benchmark data sets in order to evaluate my model. So if you're not, you cannot just change your data. Well, at least you can reduce the impact of the bias that maybe the data has. So how can we analyze those bias in your data? Well, there are a lot of solutions with that mainly uh, work with fairness evaluation. So as we talked earlier about the evaluation bias that is just use benchmark and metrics that widely spread on the literature, those metrics like accuracy, precision, recall can obscure poor performance on other groups or subgroups that are not well represented in an evaluation set. So what we do now, we here we are, I will talk just about 4 types of fairness criteria, but there are a zoo there is a zoo of fairness criteria that can be used, and you have to study a little bit of them to know if it's suitable to your method. But here we talk a little bit about some group fairness criteria that are disaggregate and intersectional evaluation. This one is really important when we are talking about racial bias, historical bias. We also have predictive parity, fairness criteria, demographic parity, and equality of odds. All of them is worth trying, is worth analyzing in your data and in your model. So this disaggregated intersectional evaluation, we already talked a little bit in the early section about gender shades. The idea was that the overall accuracy was amazing for IBM and Microsoft and everything, but when we start to disaggregate it, so we start to work in tuples. So it's not just male and female now, it's female detection. What's going on here? Male detection, what's going on here? And we start to make subgroups. Black woman face detection, what's going on here? And white men face detection, what's going on here? And that's where we found the 30% of disparity between the classes. So again, this work is really good to read, and it's an excellent work from Bolamine and Gebru. And the idea is they found that all classifiers performed failed for black faces, and mainly for black woman faces. So but just this is just, do not rely only on accuracy, do not rely only on precision. You have to understand your data in order to disaggregate them and evaluate in a better way.
And just to define them as separate metrics. So this, by disaggregating, you're dividing groups. So I have white and dark, I'm disaggregating. And intersectional, it means I'm crossing, intersecting groups. So I have dark and white. Okay, I have dark male, dark female, white male, white female. So I disaggregate and I intersect. I join attributes to evaluate. So this is the recommendation for evaluations on humans. You should disaggregate for gender, you should disaggregate for skin type, and for any protected attribute that your data set may contain. For instance, socioeconomic status. If you have this information available to you, you should produce those disaggregated and intersected metrics.
And this disaggregated solution is, when we talk about precision, it's we can call it the predictive parity criteria, is that the prediction is equal across subgroups. So we can have this equality on our data set. Other strategy that we can use too is the demographic parity that talks about the proportion of each segment of some sensitive class or protective class. And we talk about the positive outcome has to have the same proportion for each subgroup. An example, when you talk about loans, you can see if in your data set, those loans are going just for the example white male and are not going to the the female, what's happening in your data set. The positive outcome may have to be equal, have equal rates to the subgroups. And the same idea is for equality of odds. For this group, or protected or unprotected groups, have to have true positive equal rates or equal false positive rates. So you have to analyze not just the overall data set. We have to analyze these subgroups. If it's available, analyzing subgroups. And you may say, oh my God, I don't have time for this. Well, there are a lot of solutions that already you can use. An example, FairTorch is library, a Python library that has all of those fairness criteria and much more. Okay, so you can use this on your data set and to analyze it. We will show some other possibilities too. So you
Yes.
make this, it's worth.
Yeah, it's already implemented.
Yes.
FairTorch actually won a prize in a competition because a lot of people use PyTorch, I guess. If you don't use, you should use. I highly recommend you use. But it allows you to evaluate your model as for those diversity metrics with a function call. So there's no excuse not to use it, right? It's right there. So I recommend you check FairTorch. Would you like
Here,
to put your screen up
in
so you can?
fact, I'm thinking about, I don't know, you have time to show both of them.
Oh, okay, sorry.
I don't know.
We can just
Share.
recommend them. I just
Yes,
saw
I
the
believe.
time. We don't have time.
Yes, I will. We will recommend these two tutorials on fairness that has some examples of those fairness criteria. If you have time, we can show to you after the
Mhm.
the the end of the tutorial. I believe it's better, but it's interesting to analyze this and to visualize what is to analyze the fairness in a data set. So we recommend these two tutorials with the
For you to understand the metrics.
yes, yes. And one amazing work that we have to that analyze fairness, that propose disaggregate evaluation, and even so doesn't have a solution. It's I like those kind of works because science is this. We have to question ourselves every time. This work is from Bisotto, Eduardo Valle, Sandra Avila, about skin lesions. And the idea was they performed some kind of um, they started to put those black boxes in front of the lesion, and the system was still working and it was still better than random, even with 70% of the lesion all black. Just we didn't have any information, or at least we didn't have any visual
Visual.
information that a human could see. So what was going on? And the answer was we don't know, because the model was learning something that we just cannot say what is. And we, when we are talking about this kind of sensitive work, as find a lesion and find if the possibility of being a cancer or not. So it's a really nice work. We really recommend you to see that. Even if you are working with fairness and trying to solve it and try to mitigate the bias, it may still be with you, and we have to study a little more about it.
Yeah, this work got me thinking a lot about the conclusions we draw from studies, because my neural network can detect lesions but maybe it's not even looking at the lesions, it's looking at something else, and you didn't check, you didn't know. So the conclusions we draw that something can be detected, something can be modeled, I can see such pattern. Maybe the neural network does not agree with you, your model does not agree with you. So we should inspect biases in our data, in our model, not only for human reasons, as we've been talking about, but for technical reasons as well, right? Because you're going to release this great model and it's not even looking at the lesion. So, what's going on? You should find out. And it's a very interesting work.
And finally, we talk a little bit on when we talk about posts, that when we are releasing your model, well, data sheets, we already saw when we are releasing your data set, we can add a data sheet with it to show what's going on with your data. But now you can do this also with your model, and that's what the authors from post made after all the fuss and everything. They made a model card on the model they were seeing. This work was uh, released last no in 2008 and 19.
19.
It's a really interesting. We don't have time to open it, but the idea is to analyze not only what your model can do, but also what are the limitations of your model. What you intended to do here? You intended to find sexual orientation with faces. So you put your model card to anyone to point out, and no, don't do that. But it's a really interesting paper. And in the paper, they analyze some benchmark data sets as SIBGRAPI. So it's a really interesting reading, and I believe it's a really good solution to, again, to know a little bit what are you going to do, what is transparent for you. If something goes wrong, who can be responsible? Mainly when we're talking about surveillance, for instance, and face recognition surveillance, they work to side by side. So what's going on with your model? It really works with for this kind of use. So this is very important thing to
Yes.
be done.
And you should think about model cards and data sheets for data sets as someone giving you a hand and saying, there you go, just fill this form and you're fine. Because often we think, how can I know if my work is ethical, if my data set is fine or not? Should I release it or not? Start by filling the data sheet for data set, for your data set, and the model card, and you're gonna start seeing your model from an ethical perspective, and all those answers might come to your head, all those questions might be answered if you only just think about it ethically. And it is just like some questions you have to answer about your data, about your model, and there you go, you have a better idea if your intended use is ethical or not, if your model should be released or not, what uses are you proposing, and so on.
And we talk a little bit about the PyTorch and the FairTorch. We also have some really good solutions from big techs like the IBM 360, the What If tool from Google, and also the Know Your Data. All of these solutions show in a very good way. You can visualize your data and your model to see if it has some fairness criteria, if it has some bias. So you can see these. So they are very interesting works, very interesting tools to be used with your
Yes.
data or your model. And finally, all the books that we recommend. I saw that Sandra had made a spoiler here. But these three works are really good reading about the subject on bias, on solutions, and how can we think critically what we do with machine learning, computer vision, and to raise some flags when we are reading some paper, or when we are doing our data set, or when we are doing our our model. And one interesting thing, that the algorithm of oppression now is available on Portuguese, and is cheaper. So
Much
it was a
cheaper.
very it's much cheaper. It was a very expensive book, but now it's much cheaper. So we recommend this tree. It's really, really, really good to
Weapons of Mass
start.
Destruction. It's also in Portuguese. I recommend
Oh
you
yes,
reading. If anybody wants me to translate artificial intelligence, I'm available. I can translate it, no problem. But
yes.
yeah, those are
Please
great books.
call Camila.
And well, we have a discussion here, but I don't think we have time for that. I don't want to exceed the time limits. So we can just, like, you can just reflect after this talk about all those problems and all those solutions we talked about it here. There's much more on the paper. You should read the paper at least, so you think more about the work we're doing and the impacts of what we're doing. Think about fairness, accountability, transparency, responsibility. Think about the entire process from choosing what to work on until releasing your model. Think about if you're affecting anyone by that. And I don't think we have time, but
No, we
please.
have, Sandra said we have we have a little time for conclusions. So
Okay, okay, go on.
so the thing that we want to provoke a little bit used is that human-centered technology using machine learning is susceptible to bias. Humans are biased. So, okay, it's utopic to think that, oh, okay, I can finish with all the bias on my solution. No, but you can mitigate them, because as we find bias on the data, on the model, on the user, on the deployment, we also can study them. We can use some fairness criteria. We can study about accountability, transparency, responsibility, and say, okay, let's make some data sheet here for my data set. Let's answer some questions. Is it ethical? Is it legal? I can use the same thing for the model card. Can I release this model? It's okay to release it. It's okay to make it public. And of course, we have to have diversity in every step of the way. Our teams should be diverse. Our labors should be diverse. Our data should be diverse. So when we are talking about human-centered technology, we are talking about humans. So our solutions may at least try to reflect the real world. It's not enough just to say, okay, my precision is 100%, my model is the best, but your model just work for white male men from the Western.
Mhm.
No, it's not enough. And mainly when we talk about human centered and we talk about solutions that can be available to the public, we have to at least try to mitigate those bias since the beginning of the pipeline, since the beginning of the machine learning pipeline. And we cannot just let the final user to with this bomb with them. It's just not, it's not practical. It's just not practical.
Yes. Some things cannot be solved at deployment. We
Yes.
cannot expect developers to find this magical solution for the bias we release, for the models we released. So please don't put the blame on the final user, on the developer. It is our responsibility as much as it's theirs. So I think that's the main takeaway from this talk. And thank you all for your attention. I guess that's it. Hopefully, we helped you somehow, even thinking a little bit more about your work. And good rest of conference for everyone.
And if you have some questions, I think now you have some a little time, maybe.
Or I don't know.
Yeah, we have time. Yeah, we have time for
Yeah.
Okay.
questions. Okay, first I would like to thank you. It was a very inspiring, nice, and important tutorial here. And I'm reading the comments as well. Great work, congratulations, very nice and important tutorial, very inspiring. Congrats and thank you, thank you, thank you for the tutorial.
Oh, hi,
Oh, so
Alexei.
yeah, really, really nice. So I have one question.
Okay.
I have more than one question, but I have one question now. Do you think that the data sheets for data sets or model cards could be used for our like our medicine package inserts, but not our model package inserts? What do you think about that?
Uh,
It's red for that. We need more than that.
Maybe I think we need more than that, but it's a great start because it's supposed to be something easy to fill so that people don't say like, "Ah, it's too much work, I'm not gonna do it." So yes,
It happens.
there is this very
I know.
interesting very interesting work on fact the conference that someone evaluated the perspective of developing a solution and what questions should you ask from the start, and they reached a very long list of questions, and one of the works was how do we shrink this form, these questions, so that people would want to do it. So we I think we're gonna have like a bunch of different solutions as we're having right now, different data sheets, different cards. But the important thing is for you to at least try find something that you think it's easy to do, you think it's important to do, it relates to your work somehow, and you feel the specific solution. But I think yes, it should be mandatory at least to think ethically about your work, because with time people are relying on technology much more.
Yeah, nice. Do you want to add something, Virginia?
Oh,
No.
it's the same.
Okay, let me see if we have questions here. Yeah, from Moacir Ponte. From your experience, do you think all machine learning and computer vision papers should go through an additional assessment on bias in addition to technical review?
Interest point. I think
Yeah.
maybe when we release made this data sheet or the model card available in any occasion when you are send your paper to be published, and you also have to send your data sheet, send your model card. I don't know if the assessment on bias is available. It's practical because the reviewers already had a lot of
So much.
of work, and it's a technical review. It's already really difficult, and there are a lot of work with them. But with a data sheet, with a model, with something to say, well, my data set is like this, I have this kind of image, I think this should be mandatory, mainly when we are talking about new data sets, new models, and things that we can be used in real world. So yes, the answer for me is yes and no. Not to make your code available and try to to test all the fairness criteria that's available, but at least send with your paper your your data sheet, your model card. I think this should be mandatory from now on.
Uh, I think it's difficult to ask for the reviewer to assess bias in your work, because that's what I'm taking from the question. Like, in addition to technical review, should we have bias assessment? Uh, I don't think it's the job of the reviewer to assess bias. Is the job of the researcher. But I do think reviewers can ask, like, have you evaluated this aspect of your model? Have you done this and that? And I think papers should be rejected if it doesn't consider like human impacts of this work, especially if it's a human-centered application, right? We can't just play with humans as if they're numbers. I think it should come with the review, but it's not the job of the reviewer to assess for bias. It should come with the work.
Like it's the job of the paper, the people that are writing, are submitting the paper, that you have to show that, okay, I read the literature and I'm showing that I know about that.
Yes.
It's something like that. Yeah,
Exactly.
yeah, I
Because
agree.
this is the point. It's not about just being human, it's about being a good researcher. Because
Yeah.
I cannot just ignore all this work on bias and fairness and pretend it doesn't exist and just make this upsampling technique that only works on white people. It's about the literature. It's there. You should read it.
Yeah. I have a comment about the type of bias, and I'm a little bit upset with the literature that they are calling the bias. They have a beautiful name about that, and the name is shortcut learning. And yeah, we have a name for that. It's a paper, Shortcut Learning for Deep Neural Networks, I think, published at NeurIPS in maybe 2019 or 2020. And the idea is to show that the neural networks, they are learning something that are easy features, and they are catch the shortcut learning to do that. And they have another name, and the literature are discussing that, and the name is simplicity bias. And the simplicity bias, it's a very interesting, if I could say that, but an interesting thing about the technicals. So people are trying to discuss now about the technical, the stochastic gradient descent. Okay, now I can't say that. Okay, but I
SGD,
think
SGD.
SVD, yeah, okay. And maybe we need to change how we are learning the things. We need to change the techniques, how we are learning the features. And the paper said that, and I copied that thing, that neural networks exclusively rely on simplest features, even if it is less predictive of the label than all complex features. So the name of that is simplicity bias, and the people are trying to deal with the simplistic bias, another name for a lot of problems that we have.
This
So
is
we
interesting.
have one more question here, and the question is there any group, forum, or community in Brazil dedicated to discuss this 10? It would be great to talk and study more about it.
I only know international groups who are discussing that, but I can ask people, and if there's not a group for that, we can create a group for that, because I know many researchers that are interested in talking more about this, and I think we can create a new one, but I don't know any.
Yes.
And
Yes, I just know some people that are
little
working with that,
groups, yeah.
just little groups. For instance, Nina da Hora, that's that are working a little bit on that, but it's not a group. It's just some acquaintances that
Yeah,
are
but we
just
have like
discussing. But I believe
Black
we
and
can,
AI. It's
and we
all
have
about
to.
inclusion,
Yes,
but it's
yes.
Latin,
But
international.
I think we need
Latin
a
AI.
Brazilian.
Latin.
Yeah,
Oh yes,
Yes,
yeah.
but we don't
but I
have a
think we need.
Brazilian group.
No,
We should have.
not yet.
Let's create
Not
one
yet, not
right
yet.
now, right now.
Yes, now we are just creating. Go to Discord channel, and we are going to create it.
Okay. And another comment here. I used to say to my students that we have to discuss more about ethical than and less than technical, something like that. And I would like to know what you think about that.
Mm.
You can start.
I'm think the better thing, but yes, I think for a long time we are just relying on numbers, and it's not a good thing in our research field. We are always fighting about 1%, 0.1%, and when we start to see the work and to analyze it and to see the fairness on it, it's just not working. So yes, I think we can not stop, of course, not stop the technician talks, but add a little bit more about ethical, about legal, because as we are using more and more technology, we have to take care on the multidisciplinarity that is our field. I think just now computer science is is starting to look on the sides and say, "Oh, I'm not alone here. I can talk with someone about this." So I think it's a good step, but still baby steps for us. But I think yes, we need to study a little bit more on
About
other
it.
subjects than the technician ones.
Yeah.
In another tutorial, the tutorial number 1, and presented by Moacir, that is here.
Mhm.
And as something like that, I don't remember exactly the question. And the answer was, we have to slow down in
Yes.
deep learning.
Yes,
Yeah,
yes,
Yes.
yes.
yeah, we have to slow down. Yeah, I agree. I totally agree with that. Yeah, we have
Yes,
to
face
slow down.
recognition. I think face recognition is the our main example for this.
For slowing
A lot
down.
of big techs just stop the research because face recognition are being used for surveillance. And well, if we saw all those bias, all those prejudices that we're talking in this tutorial, they are all being put into the real world now, just now. Here in Brazil, we have one startup that started to try the wow, no crime area and something like
Yes. It's
this.
an
But
anti-crime machine learning
anti-crime
model.
machine learning. Well, after this tutorial, if you think this will work, rewatch it again.
Rewatch
because
it.
because no, we cannot do this. We have to slow down and think a
Yes.
little bit more, because we cannot just use machine
Yes,
learning
because
as
we're
one.
going crazy with larger models, larger data
Yes,
sets, larger this, larger that, and we're humans. We don't have the big ability to inspect larger models, larger data
yes,
sets. So we should be careful.
Yeah, nice. So I think we don't have more questions
Or more
here.
time.
Oh,
yes.
also, also. So I'd like all to again to thank Virginia, Camila, and Jefferson for this for preparing this tutorial. It was really nice and very inspiring all thing that you summarize. It's a lot of content to summarize in 3 hours. Yes, and I'd like also to thank to our audience for the questions and for being here, and the SIBGRAPI for asking me for share this great tutorial, this great tutorial sessions. So thank you so much, and I wish you all well. Thank you.
Thank you. Thank you, everyone.
Thank you very much.
Saiu? Oops.